Hi, I'm back again, and in this segment I'm going to demonstrate the concept of a subquery, or sometimes called a nested query. And subqueries can sometimes substitute for inner joins, but not always. Inner joins can always substitute for subqueries, but not vice versa, and you probably recall that from the lecture outline, my having made note of that in the lecture outline. So let me use the two tables with the minimal amount of data, because it really makes it easy to see what's going on when we don't have to muck through so much data in the tables. And so here is a question that I might want to retrieve from my database. I might want to know who the owners are of a particular pet. Okay, so say we want to know who Bentley's owner is. Now, obviously, I could go to my Rolodex or something like that, or card file system, and recall that information given the amount of data that currently exists. But if we pretend that my database grows in size and reaches some large scale where I have thousands of records, and then being able to answer a question like that's not going to be as easy as flipping open a box of index cards and looking up the answer. So this is the kind of query that would provide me with that answer regardless of how much data it has to wade through. If I want to know who Bentley's master is or owner is, then I'm going to need to access data in two tables. My selection criteria is going to use the data that's in the pet table, and my projection criteria is going to need to use the data in the owner table. So two ways to go about this. I'm going to close the relationship diagram here, and I'm going to close this current table, close up some of these objects, and I say, let's see, do you want to save changes in the design of query 1? I'm going to say no. Okay, so what that's doing is it is saying, do you want to store the instructions away for query 1? Actually, let me go ahead and store it away. So the SQL that I previously created can be stored away, and I'll call that QRY is in query, and join demo. I'll close that up, and that stores it as a new object in the database. And of course, if I want to run that query in the future rather than having to rewrite it, I would simply go to my object bar. I would filter for queries, bring this up, and it runs the instructions that were previously written in SQL. Okay, so close all that up just so you see what's happening there. I'm going to go back and go to tables here, get those open. Now, my objective was to create another query where I would identify the owner of a pet named Bentley, and I'm going to do this a couple of ways. One, I'm going to create the query in design view. So do this. It brings up the dialog box, sets up the window to support query by example, but I'm going to just close up the dialog box and jump immediately over here to the SQL editor. And one way that I could accomplish this would be to create an inner join. So that this would be a familiar technique. So I could, you should be able to relate to this. I could say select owner underscore name from owner inner join. I'm going to use the inner join operator now that I'm done demonstrating the mechanics of an inner join. From owner inner join pet, and now I had to specify the keys on owner, since this is not a unique name, since it exists in both tables, I'll say owner underscore ID equal pet dot owner underscore ID, and that will give me an inner join of the two tables. So I'm going to see a total of 3 rows in this result set if I execute it now, and I'll do it. There's 3 rows. Okay, so Chuck, Nick, and those are the 3 owners of all the pets. So there's a row for each pet, and 2 of the pets have an owner of Chuck, 1 of the pets have an owner of Nick. Hopefully that makes sense. Going back to SQL view, and this time I want to eliminate 2 of those rows, because 1 row correlated Nick with a pet record for Lucy, and the other row correlated the owner Chuck with a pet named Josie, and neither of those 2 records are what I want. What I want is the 3rd record, where I correlate the owner named Chuck with a pet named Bentley. And to do that, I'm going to have to select out, remove some of the rows, perform a selection operation. And to do that, I'll use the SQL where clause and say where the selection criteria is going to come from the pet table, where pet underscore name like, I can use a like operator because it's text data type. I could say equal or like Bentley. Bentley probably hears his name here. He's probably going to bark here in a moment, so don't be surprised. Okay, and I run the query, and there it is. Chuck is the owner of Bentley. Now, I told you I'm going to do this a couple of different ways. All right, so back to SQL view, and that would be the approach I would take if I wanted to get the result using a join operation, and probably the way I would do it. I'm favor joins a little bit more than I do the technique that I'm going to show you next. The next technique I'm going to show you will output the same data. In other words, project the same column from the same table from owner, but it's going to do it a little bit differently, and I'm just going to go ahead and write the query and then explain it. Where, put that in uppercase, where the 2 tables share in common owner ID, where owner ID, now this reference to owner ID corresponds with the one and only table that's being cited in the from clause, so that is not a ambiguous reference. Now, if it were being used in a join, I would have some ambiguity, and I'd have to qualify the name completely using the dot operator, but in this case, it treats this as a single query at this point, okay, referencing only one table, where owner ID equal, now, any, I'm introducing a new keyword there, and I'm also going to do something totally different here in that I'm going to nest another query. I'm going to select owner ID, this time from pet, so I'm referencing the foreign key field in the pet table, where, and now I want to say where pet name, I could either say equal or like, you get the same result, like Bentley. And hopefully I spell everything right. Now notice what I've done. I've put a simple SQL select statement involving one table inside a parentheses, and the effect is, and then I have a second SQL statement referencing a second table, single table, in addition to that. And by using parentheses, it's going to treat these queries much like parentheses are used in an algebraic expression. It's going to force this first query to execute, and when it's done, it will then execute the next query. Now, when the first query executes, it's going to be projecting the foreign key value that corresponds with the pet name Bentley, which it should be projecting a 1. And it's as though then, after this executes, it hands to this second query's where clause the value of 1. So the output from the first query to execute, the one that is nested properly within parentheses, the output, or what the first query projects, is fed to the where clause of the second query. First query executes, its output is given to the second query, and it executes. And the end result, if you trace the data that's stored in the table, and that's why I wanted to use a minimal amount of data so you could manually go through and see what's happening, the end result is when this query executes, it's going to project a value of 1. It's done, and it will be as though there is a value of 1 used in the where clause. So when the second query executes, it's going to execute like select owner name from owner where owner ID equal 1. So two things to understand here, to be able to conceptualize, is that when we work with subqueries or nested queries, we force a situation where the queries will execute in sequence, and we can control the sequence by surrounding the queries in parentheses. Now, it is possible, I'm not going to demonstrate it, if you were taking a full-blown database programming class in the computer science curriculum, we would spend far more time on this, but it is possible. You may see this in the future if you are in a situation where you ever have to work with SQL in any serious way. You may see that it's possible to nest queries to any extent necessary to produce the end result. In other words, I can have a query nested inside of a query, inside of a query, inside of a query, and that can go on indefinitely, and I just keep framing everything properly with parentheses so that in the end, the query that is surrounded by the most interior set of parentheses will execute first, and then it begins to execute the queries in this kind of chain reaction way by executing the queries from the innermost set of parentheses to the outermost set. And with each query, the projected output is given to the where clause of the next query in sequence. And the any operator, I want to say just a little bit more about this. There's two operators that can be used, any and all, and I don't want to go down this path, but I'll try to point something out and then not go a mile deep here. But what any does is it will force a repetition effect on this select statement. So in the event that the first query projects more than one row of output, then the SQL will essentially drop into a loop and begin firing the next SQL statement, and it will take the first row of output from the first query and execute it against the select statement. Then it will take the next row of output from the first query and execute it against the current query, the highlighted query I have here, and it will continue to execute the SQL statement, the second highlighted SQL statement, for however many times is necessary, or for however many rows of output result from the first query. And if you understand all that, great. And if you don't, certainly this is something that if you ever needed to learn, there's resources available that you could learn this to a much greater extent. So my purpose in showing you this is just to give you some sense of how powerful SQL is, how many options there are, and I'm really just in this course only being able to show you the tip of the iceberg. But SQL is incredibly powerful. There's a variety of different ways that we can manipulate these tabular storage structures to combine the data and to order the data and so forth in just about any way imaginable. All right, so all this is fine and dandy. If it works the way I say it does, then when I run it, I should get one row of output, and that output should be a row that says Chuck. And there you have it. Okay, so that's the idea of a nested query or a subquery. Now I'm going to do one more thing that's access specific, and I think I can do it with a nested query. Certainly I can do it with a join, and I may go back to my join and do it if this doesn't work out. But the way this query is written, it executes in a very static way. In other words, if I execute this 100 times, it's always going to produce Chuck, 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 because it's always using Bentley, that static value, as the selection criteria. So what would be useful and what's possible in Access is to create what's called a parameter query, where I leave the data that's evaluated in the where clause variable and input it as the query executes. I input the data at runtime. And so to do that, I think I can do it with a nested query. I'm not absolutely certain, but we'll find out. If not, I'll certainly demonstrate the concept of a parameter query with a join here in a moment. But I'm going to surround a message here with square brackets. So the syntax is such that you have to use square brackets. And I'm going to put in a message that says enter pet name, and then close that off with another closing square bracket. And if this works the way I think it will, I'm going to get a message, and when I run it, and it comes set up with enter parameter value, enter pet name, and in this case I'll put in Bentley, and it will, when I say OK, show me Chuck. I'm going to go back, and as you recall from the data, another pet belonged to Nick, a pet named Lucy. So if I run it this time and say Lucy, if this works the way I tell you it does, then it should produce Nick in the result set, and there it is. So the idea of a parameter query, which is something that I alluded to, I think, in Module 6 that I never got around to demonstrating, has now been demonstrated. And what a parameter query does is in Microsoft Access, if you want to make that selection criteria variable, you can put in place of an actual value in the SQL, you can put in a prompt surrounded by square brackets, and then when the query executes, it'll ask for the data at runtime, and you'll be able to put in whatever you want to. So it certainly makes the query more flexible if you do it that way. All right, and I'm not going to demonstrate that, but it works the same way with an inner join. Anywhere I want to do that, I would just go ahead and build my prompt into the where clause, and then it'll execute in a more flexible and variable way. Okay, so that should conclude things on the topic of subqueries and on parameter queries. And again, I want to point out that subqueries provide another option. Some people like to use them for some problems. It actually simplifies the logic, but they're basically an alternative to an inner join in some instances, not always. Now again, the inner join will work in place of a subquery always, and sometimes a subquery will work in place of a inner join. One thing I will point out, let me do that, and if I go back over here to design view, when you work with nested queries, one thing to be aware of, and this will influence how you go about writing the SQL, how you go about solving the problem. If you're working with a nested query, then ultimately the result set will be projected from a single table. So I can only use fields from a single table. If I want in my result set to include fields that are in multiple tables, then I'm going to be required to do that using an inner join. Okay, so that wraps up the discussion of subqueries and of parameter queries.